Hello, class, and welcome to the next episode of Your Crazy Science Teacher in Quarantine. This episode, we will be reworking our boiling point labs. Quarantine. I know what you're thinking. Miss Smith, yes, we do boiling point. Thank you, COVID-19. I can't wait to do that really long, in-depth conclusion again. Before we get started, let's make sure we review our lab safety. Long hair, lay it back. Don't touch your face. Before we start boiling stuff,
Boiling for sure.
asking. Let's review. What was the question we were answering? Asking. Can boiling point be used as a characteristic property to determine the difference between water and isopropyl alcohol? Don't touch your face. Now we have our scientific question. We write our hypotheses. There is no better person for the task, Miss Elrath. Quarantine.
Oh, hey! Miss Elrath here. I just heard from Miss Smith, your crazy quarantine science teacher. You are trying to write a hypothesis. I don't remember the last time we wrote a hypothesis. We were writing hypotheses. We wrote a hypothesis weeks ago. And so I'm thinking back. I know that a hypothesis is a statement that begins with if. If the moon is made of cheese, then astronauts should really just be called cheese explorers, because I think astronauts are going to the moon just for the cheese. Yeah. So is that a hypothesis? Hypotheses. First of all, is there a way I could make a prediction based on my hypothesis? I could predict that astronauts go to the moon to eat cheese. Could I design an experiment? Yeah, I could send some astronauts to the moon and see if they eat cheese. And lastly, is there a dependent and an independent variable in that case? I touched my face now. So let's see here. I'm not really sure what I would change or what I would measure in the case of my astronauts going to the moon to eat cheese experiment. So let's use a different example. I touched my face. What about a boiling point lab? Okay. I think I know what I'm doing now. So let's see here. Let's go to a slideshow that I made. Okay. So my apologies getting off task with the astronauts going to the moon, which is actually just a land of cheese. I think I might be losing my mind a little bit. But let's think back to our boiling point lab. So we know that we need to have an if, then, because statement. So let's start with if. If you are trying to identify what each substance is, and you have two different substances, then you can boil each substance and record the temperature at which they both boil, because boiling point is a characteristic property of substances that allows us to identify an unknown substance. So I have to ask myself a few questions based on that hypothesis. And one more time, I'll just read it all together. If you are trying to identify what each substance is and you have two different substances, then you can boil each substance and record the temperature at which they both boil, because boiling point is a characteristic property of substances that allows us to identify an unknown substance. So, can I make a prediction based off of my hypothesis? Yeah, I could predict that the water is going to boil at around 92 degrees Celsius. And I could predict that because my research tells me at sea level, water boils at 100 degrees Celsius. However, as you go up in altitude, or elevation, the boiling point drops. And therefore, at Frisco's elevation of around 9,200 feet, the water is likely to boil at around 92 degrees Celsius, whereas the isopropyl alcohol will boil closer to 75 degrees Celsius at altitude, or at an elevation of 9,200 feet. Can I plan an experiment to represent my hypothesis? Yeah, I think we did that, remember? And lastly, does my hypothesis have an independent and a dependent variable? Independent variables are the ones you change, and the dependent one is the one you measure. So let's think about that for a minute. I'm going to take you back to 6th grade science. All right, so here, what is our independent variable going to be? Our independent variables on our x-axis, and our y-axis has our dependent variable. In the case of the boiling point lab, we said the independent variable was time in seconds, and the dependent was a temperature in degrees Celsius. So have we identified a dependent and an independent variable? I think so. We just answered yes to all 3 of those questions. And if we say yes to all 3 of those questions, don't start singing, then you have a hypothesis. And you're right, if you said yes to all 3 of these questions, then you've got yourself a hypothesis. That is an if-then statement, but that is not a hypothesis. Okay, I hope that helps you remember how to write a hypothesis. All right, see ya. Bye.
Wonderful hypothesis, Miss Elrath. The independent variable's the one you change. The independent variable's the one you change. The dependent one you measure. Get it wrong, you'll feel displeasure. Independent variable's the one you change. So let's think. Don't touch your face. It is time to cut to the lab with Miss Bailey and her 2 science assistants, Sunny and Cal. Quarantine.
Okay, here we are back in the science lab with your not so crazy science teacher. I kind of think I'm the sanest of the science teachers. The not so crazy science teacher, because I feel like Miss Smith really has that one dialed in. Science experiments with not so crazy Miss Bailey.
Not so crazy.
Let's get this thing going. I think I'm the sanest. Safety goggles on. We are going to now boil substance B. We are using the exact same pot, the exact same amount of liquid, exact same thermometer. Let's get this thing going.
50 degrees, not boiling. 70 degrees, not boiling. 92 degrees and boiling.
Boiling for sure. Thank you, scientist.
You're welcome.
So at least I got that going for me.
Not so crazy.
All right, and now it's time for substance. I think I'm the sanest. We are using the exact same pot, the exact same amount of liquid, exact same thermometer.
Not so crazy.
Let's get this thing going. So what temperature did substance A start boiling at?
73 degrees.
Perfect. Thank you, lab scientist and unsafe scientist.
Not so crazy. Data collected and our scientists safe. Quarantine. It is time for us to do the last part of this conclusion.
So the next section is on reliability. And when we're talking about a scientific experiment, the reliability is whether or not you would get the same results if you did the experiment again. So you can talk about reliability of your data or reliability of the experiment itself.
Good. Bring it here. Bring it here, Sadie. Bring it here. Bring it here. Good girl.
See, the same results over and over and over. That's reliability.
Here you go. Go get it. Bring it here. Bring it here, Artemis. Artemis, bring it here. Artemis, you're not being reliable. Bring it here. Come on, Artemis. Not being reliable.
So here's the section of the lab that you're going to be filling in. You need to come up with some ways that your experiment was not reliable. And think about it, nobody's perfect. There's definitely going to be some reasons that your experiment was not reliable. And then you need to go on and explain how you would improve your experiment in the future to make it more reliable. So think about it. Can you think of some ways that maybe your experiment was not reliable?
Time. Cameron, time. Cameron, what's the temperature? Oh, it's 36-ish, 20-ish.
Thanks for tuning in. Your crazy science teacher in quarantine. Again.